So a beam antenna focuses or directs the RF energy in a desired direction. We talked about my 2-element beam pushing it out in one direction. Remember gain, an apparent increase in power in the desired direction. So a Yagi is a passive series of elements in front of or behind the driven element. It was developed in Japan by a couple of researchers. Yagi was one of the name of the researchers. So a quad is a square-shaped wire loop element, and it's a full wave instead of a half wave. So here's a beam antenna. This is a Yagi. This would be your driven element with one reflector behind it and 1, 2, 3, 4 directors in front of it, all successively shorter generally than the driven element. So these are shorter, the reflector is a little longer, and they're spaced appropriately for the maximum gain. And here you've got, these aren't popular anymore. They used to be 2 aluminum elements with a wire stretched between them. It made a triangular quad, and it actually worked very well. A regular quad element is 4-sided, either a diamond orientation or a square, but it's a full wave, not a half wave. These are half wave elements. These are full wave elements, so they're twice the size.
So 10 meters would be pretty long, but if you put it in a quad, it's usable.
Driven element connected to the radio by the feed line. Reflector element is on the backside. The reflector has to be a little bit longer. It's usually like 5%, 6% longer. Antenna supports. We're talking about towers here or a mast. I have a mast up the side of my house. I'm only in a double wide, so I can't put up a big tower behind my place. I don't have enough room. But I just put up a 20-foot mast, and I put this on a sleeve, I guess. I have a standoff with a sleeve in it, and I put my rotator at the bottom. So I rotate the entire mast. Everything on the mast rotates. So I can put several antennas up there. I do. I've got a TV antenna, I've got my 7-element beam, and a smaller antenna for 440. And they all rotate the same. Covenants and antenna restrictions must be considered.
So you have all these antennas, they're connected to your same radio, like you connect multiple?
No, I've got separate feed lines. In fact, what I do is I have a relay out here with one feed line coming back into the shack, going out to the relay, and then the separate lines coming off that relay. So if you've got coax, you can run DC on that coax, and the RF doesn't care. It doesn't even see it. So you run DC on that coax, and you can switch the relay without having a separate line.
So it's just like a splitter to each one, and then you just pick
Yep.
which one you want, and it
Yep.
only operates one at a time, but they are technically all connected.
Yep.
Or you can have a manual switch, you know, to switch. I've got a manual switch on my 2-meter radio between a Yagi and a vertical. And I've got a switch between 2 HF radios on the same antenna.
What is a beam antenna? Okay.
Charlie,
Alpha, beta, Charlie, and delta.
Charlie.
Which is the following describes a simple dipole parallel to their surface.
Alpha. The far side, Bravo.
Bravo. Horizontally polarized. Disadvantage of a rubber duck antenna supplied with most handheld transceivers when compared to a full-size quarter wave. What would be the disadvantage? I like Chuck Charlie. Yeah, it doesn't transmit or receive as effectively. And people will talk disparagingly about their, rubber duck antennas.
But the nice thing is you can put them in your pocket, or you're not dealing with this jamming you in the eye or something, so they have their place.
The real short ones are the worst, and they're often likened to a dummy load. Next.
Charlie.
So what's the disadvantage of using a handheld VHF with a flexible antenna inside a vehicle?
Alpha.
Alpha. What's the approximate length in inches of a quarter wavelength vertical antenna for 146 megahertz? 112, 50, 19, or 12 inches? Charlie, 19 inches. What's the approximate length in inches of a half wavelength 6 meter dipole antenna? 468? And yeah, 112. In which direction does a half wave dipole radiate the strongest signal? Rod, to the answer. And what's the purpose of a capacitance hat on a mobile antenna? To electrically lengthen a physically short antenna. Yes. What's the disadvantage of using a shortened mobile antenna as opposed to a full-sized antenna? Charlie, is operating bandwidth may be very limited. Yes. So when you shorten an antenna physically, you can tune it. You get it tuned so it'll work. But your limits of tunability will be really narrow. You get just barely off that frequency and you'll have to retune it again.
That's sometimes called Q. You'll hear people talking about the Q of an antenna.
The Q is efficiency.
Yes.
And the efficiency goes up as the bandwidth decreases. So you get your efficiency up, but the bandwidth will be very narrow. What's the advantage of a 5/8 wavelength whip for VHF or UHF mobile service? It has more gain. Which of the following describes a type of antenna loading? I think that's correct. Electrically lengthening. Yes. You put inductors in there, and that loading
An
will
inductor
shorten the
is a
antenna,
coil
make it
of
look
wire.
longer. And it is not the amount of wire in there. People have the idea that, okay, I need a short antenna for 80 meters, and I need it 20 feet shorter. I'll just take 20 feet of wire and wire it on this coil, and I'll stick it in there, and that'll work. No. So you've got a certain amount of inductance that coil will develop, and that's what you're measuring in order to get the antenna shorter.
Okay, I heard of Bravo.
Which of the following is a common way to adjust the feed point impedance of an elevated quarter wave ground plane antenna to approximately 50 ohms? Bravo. Slope the radials downward. And which of the following best describes the radiation pattern of a quarter wave ground plane vertical? Quarter wave ground plane vertical. Omnidirectional and azimuth. What's the radiation pattern of a dipole in free space and a plane containing the conductor? Do you get that question?
No.
Yeah, that's weird, the way they stated it. So the radiation pattern of a dipole in free space, like this, okay? This is the plane of the conductor. So we're looking at how that looks if you're looking down on it. What does it look like when you're looking down on that wire antenna?
Delta, yeah.
Has a pair of lobes on one side of the antenna and a single lobe on the other?
No?
No, it's a figure eight. So
Remember the donut?
Okay.
Right, that's what I was thinking.
Yeah,
Trying
so-
to get into a donut, but
it's going to be, the radiation is going to be perpendicular to the wire. It's going to be going out this way, going out that way. They're going to be fat figure eights, but it will be going like a figure eight. How does an antenna height affect the horizontal radiation pattern of a horizontal dipole HF antenna? Yeah. If the antenna is less than a half wavelength high, the azimuthal pattern is almost omnidirectional. As you get down below a half wavelength, it starts to squeeze upward, and you get more and more of the radiation going up. So if you want to hear DX, you've got to get it up above a half a wavelength. Where should the radial wires of a ground-mounted vertical antenna system be placed? These are the radial wires of the ground-mounted vertical.
I'm listening.
Charlie.
Sure.
Yeah, Charlie, on the surface or buried a few inches below. So You could leave them right on the surface, but people might trip over them. You know, I've had some people say, you can just leave them there, let the grass grow up through them, and you won't even see them.
Yeah, but a bear will dig them up.
Oh yeah, and you go through with a rake, you're gonna rake the leaves up right, you're gonna rake up all your radials. So I buried mine. So how does the feed point impedance of the horizontal half-wave dipole change as the antenna height is reduced to 1/10 of wavelength above ground? The feed point impedance, okay, remember in free space, half-wave dipole has a feed point impedance of 72 ohms. But as we get it closer to the ground, or as you lower the ends closer to the ground, that feed point impedance comes down closer to 50 ohms. So it should be beta. It steadily decreases. How does the feed point impedance of the half-wave dipole change as the feed point is moved from the center towards the ends? Alpha. It steadily increases.
Sometimes called an off-center fed type.
Yeah, I mean, you have some interesting effects with
So is
this.
that an end thing?
So you may have a dipole where the center isn't in the middle. The feed point is a quarter wave out or a quarter of the wave on one side or some variation thereof. And what they find is that now it's got resonant points at the even harmonics. Oh, 80, and, 40 and 20. Oh, this is cool. I got a multi-band antenna. And this is what they do. They change it. But the downside is that you've got that high impedance that you've got to tune out. It still is going to require a tuner, to get the full band. What is the feed point impedance of an end-fed half-wave antenna? It depends, but it's going to be high. You know it's going to be high. So it's not 50 ohms, and it's not low. Approximately 300 ohms, maybe with certain ones, but it's probably very high. Which of the following is an advantage of using a horizontally polarized as compared to a vertically polarized HF antenna? Alpha. Somebody said alpha. That's correct. You have lower ground losses. So that's one of the problems with a vertical HF antenna. If you don't have a good ground, and most of us aren't going to put out 360 radials. We'll be lucky to get 18 of them out, like me. And I have it on the very back of my lot, and on the other side is somebody else's property, and I have no radials over there. So yeah, I have some ground losses I got to worry about. It still works for DX.
You can make stuff work even if it's not perfect.
If it's not perfect, it will still work. What is the approximate length for a half-wave dipole cut for 14.25 megahertz? We're talking about 468 divided by 14.
32.
Yeah, so 32 feet. That's a half wave at 20 meters. What's the approximate length for a half-wave dipole cut for 3.55 megahertz? Again, 468 divided by 3.5, and you're going to have around 130 feet. And the approximate length for a quarter wave now, not a half wave, quarter wave monopole cut for 28.5 megahertz. When they say monopole, they're talking about a vertical.
Alpha.
So, somebody's an old CB'er. You said that too fast. That works. How does a screwdriver mobile antenna adjust its feed point impedance?
I heard Charlie.
No, it's travel. By varying the base loading inductance. So it's got that big coil, and it's moving that coil up and down past the connector. So that's the inductance.
Is the whip into that also?
Yeah, if you change the whip, you change.
Yeah, if you change the whip out, if you change the size of the whip, it'll change. What's the common name of the dipole with a single central support? Alpha. Inverted V. Alpha. Okay, Yankee antennas. How do Yankees work?
I've been trying to figure the term out.
Dipoles, ground planes, and random wire antennas are a single element. An array antenna is more than one element. It always has a driven element. With a driven array, like you have on a TV antenna, power is fed to all the elements, or most of them. With a parasitic array, you've got one element that's fed, that's the driven element, and then the remaining elements radiate power coupled from the driven element. They're not directly coupled. A Yagi is an array antenna. Radiation from the elements combine constructively and destructively to create a directional radiation pattern. If in phase, the constructive interference increases in signal strength. If out of phase, destructive interference decreases signal strength. So Yagi antennas are parasitic array antennas with two or more elements. They have a half-wave driven element and one or more parasitic elements called reflectors and directors. The reflector is always longer, the directors are always shorter.
On field day, you want to come out to see the antennas that we've got for field day. Mike Bach has them. They're on trailers. They're fit together with, and they've got crank up towers on them. And then you hook them up to a radio. It's amazing what you can hear and what you can do with those huge antennas. But the amount of metal you have in the air is one part of how it works.
So yeah, it's a trade-off. A Yagi antenna can be big and awkward for the lower bands especially. So it's a trade-off with gain versus awkwardness, size, and money. So Yagi structure and function. Reflectors, there's normally only one. Additional reflectors don't really make much difference. About 0.15 wavelength, or an eighth of a wave behind the driven element, and about 5% longer than the driven element. Directors, there's one or more. One or more additional directors has little effect on the front to back ratio. Additional directors increase gain. And they're also about an eighth of wavelength in front of the driven element and about 5% shorter than the driven element.
Each.
Yeah.
So it will be,
As you get further away from the driven element, sometimes they're exactly the same and the spacing will vary. A 2-element Yagi, one reflector and no directors. About 7 dBi front to back ratio. That's theoretical. At 7 dB. You almost never see that. Front to back ratio is approximately 10 to 15 dB. A 3-element Yagi, one reflector and one director, has a theoretical gain of 9.7 dBi, almost 7.5 over a dipole. So how noticeable is that? 7.5 dB. Sounds like a lot, but on your receiver, you'll see your S meter, and it's gauged in S units, and each S unit is 6 dB. So when somebody has increased their signal strength 7.5 dB, it's just over 1 S unit on the S meter. All right, is how noticeable is that? An S unit is just twice what you can barely tell the difference of. 3 dB is just discernible to the human ear, a difference in signal strength. So 6 dB is just double that. 7.5 dB, a little more than that. So it's noticeable, but it's not like,
especially at the margin. You know, when you hear a weak signal, when you can't quite hear what the Yagi, you would probably be able to hear it. If you can hear noise, but you can't discern it, that's where it comes in.
So it's not going to be night and day, but it might be the difference between hearing the signal and not hearing the signal when it's right at the noise level. So you're tuning around and you're trying to hear DX stations or whatever, and you can hear this guy coming, you just barely make out his signal. Well, it could be, 1 S unit over the noise, and it'll make that difference. The Yagi antenna offers greater gain than dipoles, isotropic, 5/8 waves, J-poles, and others. The front-to-back ratio is the power radiated in the major lobe compared to that in the opposite direction. And Yagi construction can make a difference. The gain of a 2-3 element horizontally polarized, the gain of 2 3-element horizontally polarized Yagi antennas spaced vertically a half wavelength apart can be phased and be approximately 3 dB higher than a gain of a single 3-element Yagi. So what they said was, if this is mounted on a tower like that, and I put another one of these a half wave below it, I can double my signal strength. Not bad. So, design trade-offs, adding directors do increase gain, but it also makes the antenna longer, that increases wind load, increases spacing between directors, increases gain also, and at some point the gain starts to decrease. And larger diameter elements increases bandwidth. So I did this antenna using half-inch flat aluminum stock from the hardware store. Oh, it's rock band is all get out. We'll do the, 1.2 to 1 across the entire band. So you can use that to your advantage. Changing spacing and the length of elements also changes gain, front to back ratio, and feed point impedance. So, azimuthal projection map. Why would you want to use an azimuthal projection map when using a directional antenna? What is an azimuthal projection map? Who can tell me?
Gives you the azimuth of the degrees on what direction actually.
So it'll be on,
Pointed.
yeah, you are correct. You've seen these globe maps that look like the whole world has been flattened, the globe has been flattened on a flat map. Well, an azimuthal projection map has taken your location and put it in the middle. And now everything is out away from you. So you look at Australia, and it's off on the edge of the map here, and you've got a direction directly to Australia on the shortest distance.
And it will be in degrees.
It'll be in degrees.
So we'll tell you, you need
So-
271 degrees.
Right. And if you've got your rotator set with degree markings, you can just rotate around and point to Australia. So that's the idea. Shows true bearings and distances from a specific location, such as your base station.
That's something on a computer, is that what you're talking?
Probably today, but the people used to use a flat map. They just had a map with your location on it, and then had the 360 degrees plotted from that.
Wouldn't you need to know the grid, so to speak, of where you're trying to reach?
Well, yeah, if you know,
So if I have like the grid, I don't know, say Seattle or something,
Seattle
the exact town I want to talk to, that
Arizona,
grid, so
yes.
then I obviously know what my azimuth, we can just point it.
yes,
Okay.
actually for most people that's more trouble than it's worth, but it's something that you could do.
And now, most people aren't using paper maps on the wall. They're using a computer app, and it brings up the map, and it puts your location in the center of the map. And
Yep.
you just go in and out of it as you need it. Okay. Impedance matching. Most Yankee designs have the feed point impedance of 20 to 25 ohms. And that's because the antenna element is pretty thick. It's not a wire, and it lowers the feed point impedance. Well, okay, so how do we get the feed point impedance back to 50 ohms? So there's a matching network on each antenna. Usually it's something like this, a gamma match on the left, but it could be something else. There's different ways to do it. I've used a kind of a Y configuration, but the gamma match is the most common one. You've got, this is your driven element, or one side of the driven element. You've got a short section here with a little capacitor. Sometimes it's variable, sometimes it's not. Sometimes you can just slide this back and forth inside this bracket, and it will change the capacitance enough that you can get your tuning done.
Remember gamma match.
Okay, an adjustment capacitor can be an actual capacitor or a metal rod or wire placed inside a metal tube, adjusting the capacitor in position of the strap for 1-to-1. It doesn't require that the driven element be insulated from the boom.
That's a question.
Yeah, this is called a plumber's delight construction, where everything is mounted directly and there's no insulation required. Different antenna types will or will not require insulation from the boom. In this type of construction, when you've got the boom here and your elements mounted directly to it, remember we talked about the center of your dipole being the high amperage point and the high voltage points out at the ends? That means that there's a voltage null right here when you connect to the boom. Doesn't affect it, no effect whatsoever. So that's just one thing to keep in mind. So there's also a beta match called a hairpin match, shorted transmission line stub placed at the feed point. I use that method to tune my quad. So which of the following describes an azimuthal projection map?
Bravo.
Bravo. A map that shows the true bearings and distance from a specific location. Which of the following is typical of the lower HF frequencies during the summer? Did I hear delta?
Yeah.
Yeah, high levels of atmospheric noise or static. That's really common because of thunderstorms. When we start getting, and it could be 300, 400 miles away. So we have clear skies, and over on the other side of the Cascades, they're having a thunderstorm, and it's real obvious. And what you'll see is your S meter go wham, 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 every time there's a lightning strike. It'll peg it, S9, back down again. So which of the following would increase the bandwidth of the Yagi antenna?
Alpha.
Larger diameter elements, that's correct. What is the approximate length of the driven element of the Yagi antenna? Quarter wave, half wave, 3/4, or 1 wave?
Bravo.
Yes, half wave. How do the lengths of a 3-element Yagi antenna and director compare to that of a driven element? Anyone? Alpha. The reflector is longer and the director is shorter.
You could also say D though. The relative length depends on the frequency.
That's not the answer they want.
No kidding.
What's the primary effect of increasing the boom length and adding directors to a Yagi antenna? So increasing the number of directors, that's going to increase what?
Gain.
It's going to increase gain, alpha. And at some point, you've got a point of diminishing returns. So you can keep adding directors, but the whole boom length starts to get longer, the wind load gets longer, and you're not getting much more gain. So there's a trade-off there. You get to a point around 7 elements, and it's not worth going any further.
And the cost gets higher.
What is a beta or hairpin match?
Alpha.
Yes, shorted transmission line stub placed at the feed point of the Yagi antenna to provide an impedance match. What does a front to back ratio mean in reference to a Yagi antenna? Charlie. Right. What is meant by the main lobe of a directive antenna? The direction of maximum radiated field strength of the antenna.
I know.
Yeah, it's not C, it's not maximum voltage, it's not the point of maximum current, it's the direction of the maximum radiated field strength. In free space, how does the gain of 2 3-element horizontally polarized Yagi antennas spaced vertically a halfway length apart typically compare to the gain of a single 3-element Yagi? Bravo, approximately 3 dB higher. So you double the number of antennas, you can double the gain. Now,
Theoretically.
theoretically.
Yeah.
So you've got a phasing harness that goes between there. You've got to connect it with coax. And the spacing actually isn't that critical, but the phasing harness is. The phasing harness has to be a correct wavelength separation. And if you can do that, maybe say you've got 7 elements on an antenna. Well, you can add more elements, but you're not really getting much more gain. You're certainly not going to double the gain of the antenna. So at some point, a single antenna doesn't do it anymore, but you add another one and you can double the gain. So you might have 2 7-element antennas. Maybe, Chris? and then you can really get some work done. The guy up at Roseburg on 2 meters uses that system. He has 2 stacked antennas. I think he's using
They're tied together?
Yeah, they're phased together, and boy, does he have a signal.
And they're 70 feet up in the air and he's running 800 watts. But he can hear us and we can hear him.
Yeah,
So the antennas work in both ways. It's just amazing that you can.
and Steve works them on a vertical. I mean, he can hear so well up there that Steve's working on.
Well, I've got a 5-element Yagi too, so I can point it at him.
Yeah.
My vertical doesn't, I can't get him on my vertical.
Oh, really?
No, somebody does, one of the
There's
guys.
somebody in the valley that does. Which of the following can be adjusted to optimize forward gain, front to back ratio, or SWR bandwidth of a Yankee antenna?
Delta.
I would say all of the choices, yeah. Yep. Which HF antenna would be the best to use for minimizing interference?
That's what I would go with, but I'm not sure.
Yeah, directional antenna is the answer they're looking for. An isotropic antenna would be the best for minimizing interference because you wouldn't receive anything.
Well, if you could just build one, it'd be great.
Yeah, right, it's theoretical.
Okay, so directional.
And so think of lightning,
Yeah,
you
so
know,
you can,
got lightning all around you. If you can just take this pie, you just don't get as much lightning, is what it happens.
either that or go between them.
Which of the following is a characteristic of using a gamma match with a Yagi antenna? Remember, a gamma match is your parallel rods using capacitance to change your impedance.
Alpha.
Correct. Doesn't require the grignard to be insulated from the